Hello everybody and welcome. My name is Göran Marby. Maybe some of you know me, I'm the outgoing chair of BEREC. Next year, for the first time in 4 years, I will not be a member of the board of BEREC, which I'm looking forward to, and I think the rest of the BEREC community as well. One of the things that over the last years has creeped up on us is the discussion of machine-to-machine and Internet of Things. I've been lucky enough to be that old that I've seen Internet grow, and I think to many extent the machine-to-machine is really the next revolution of Internet. And one of the things you can say that is talk about numbers. When I gave my first speech about machine-to-machine about 4 years ago, I think someone said it's going to be 20 million devices, and then it was 100 billion, and now it's 200 billion or far. And every time I go to a conference, that number increases. Which relates to me the question, how many devices are there in the world? And what is a device? And hopefully we will get that answer today. As you know, BEREC is working on a study when it comes to drafting a report on machine-to-machine. So we thought it was very timely to have this discussion here. As we know that some of the traffic, not all of them, in machine-to-machine will actually be on the Internet. There will also be a large portion of that traffic that goes directly under the Internet layer, on the technical layer. So maybe today we will get the answers to things like, why do you need a SIM card in every device? How do you handle privacy when everything is connected? What about where will the traffic terminate in the future? Will it be a cable-like mobile operator scheme, where all traffic is terminated in the mobile network, or it will be continued in the fixed network? But maybe more importantly, how do we avoid to create new monopolies in a very fast-changing technology? And how do we make sure that we give European companies the benefit of the doubt and make sure that they can profit on this one and build services for end users? I hope that we will get the answer to those questions and many more during this excellent panel. And with that, I will hand over to Kara. Thank you very much.
Thanks, Göran. Thanks for your work in BEREC. You have been an expert of the Internet over the past 4 years, which is my hobby, so I have been very happy about that. I think now we are talking about something. The Internet has changed the way we work, communicate and trade. And we are now talking a little bit about those issues that were mentioned by Commissioner Oettinger before, this new digitalization area. The effect of Moore's law have reached a new stage, and the dramatically decreasing cost of processing data make new things happening. I'm also tempted to ask this evolution paradigm. I leave it up to you to decide whether we are talking about a revolution or an evolution. But it definitely will affect the development of IoT and M2M will affect many sectors that were mentioned before, like health, energy, transport, manufacturing. We see very different sectors, very different business models, but they do share a few common characteristics. We talk about M2M when machines communicate with each other in a fully automatic way. There is some debate as to whether limited human intervention should be included, yes or no. BEREC has decided not to fix on a particular definition for the time being, as the developments are at different stages and are still in a flow. But what we do see is that most M2M applications, they need connectivity, but they don't produce huge data volumes. They produce irregular, sporadic data volume. There may, of course, be also video applications in the future that will then require more data volume, but not for the time being. In that sense, connectivity, while it's a necessity, doesn't really account for a large proportion of the revenue opportunity in the value chain. There is one thing I think that is very important for this debate of global markets, European markets, cross-national markets. M2M applications really have a chance of becoming such a market because cars, if they drive, usually cross borders. And refrigerators are sold from one country to another. So we truly see more than national markets. There is also one feature that plays a big role later on when we talk about competition is that many M2M devices have a very long lifetime. It's not like a smartphone that you throw away after 2 years. A refrigerator can live for quite a while. The business model is usually a B2B business model, and it may also be a B2B2C business model. If many end-user devices are included. Perhaps next slide? Or can I? No? Okay. We have drawn up one particular value chain typical example. However, the players we have defined can obviously take more than one role, and there are also different constellations which we've mentioned in the end of the paper. However, typically you have the connectivity service provider that is a telco, you have an M2M service provider that may provide a platform, and the typical M2M user is not the end user, but it's a car manufacturer, it's an energy company that then spreads devices to the mass market. Now, what are the conditions required for IoT and M2M to thrive? Obviously, we need sufficient resources, whether it's spectrum or identifiers, and we'll talk about them. We need a legal framework that's fit for IoT and M2M, and as was mentioned before, we have to ask the question whether a framework that was devised for voice telephony is fit for these applications. Roaming plays an important role as we are in a transnational market. And obviously, if the consumer doesn't accept the applications, the whole thing will not work. Therefore, privacy, security, and interoperability are important points. I'll focus here on those points where BEREC has recognized the need for special treatment, and just give you a few points. Otherwise, you will have a chance, I think, to comment on the full paper at a later stage. Now, one of the important points is the identifier question. These numbering issues are not our genuine responsibility. It's primarily dealt with CEPT and ITU at an international level. However, BEREC has, for the time being, not identified any scarcity issue in numbering preventing a thriving of M2M applications. We currently think different national solutions can be chosen. Some countries have opened specific M2M number ranges. A more tricky issue is the issue of the mobile network codes, because here you may run into a lock-in problem, and here you may also run into a scarcity problem, as normally countries only have 100 codes, and obviously you have the question whether you want to give a right of application to M2M users like car manufacturers. The other solution that's currently discussed is over-the-air provisioning of SIMs. I'll come back to that later. And also because of the global nature of these connected devices, extraterritorial use of numbers is considered a key to have these business models thrive, and it is happening today. So national regulators are getting more open to this, but obviously have to check about security issues. There are alternative ways. You could also use international ITU numbering resources, which some companies are going to that direction, and the Commission has recently suggested that an ETNS resource might also be a good solution for a European market. These are issues that we will have to check on. And obviously there is one question which we haven't included in the consultation, but obviously it's a question whether IPv6 IP numbers are a relevant identifier for the future. I recall that when the IPv6 discussion started, it was meant to be to connect devices. However, for the time being, we are more confronted with mobile applications. Therefore, we would be very interested to hear from stakeholders what they think about the prospect of IPv6 IP numbers in this area. Another issue that we have been confronted with repeatedly by stakeholders is whether these applications are to be considered as electronic communication services. We are discussing this definition in many contexts, also in the OTT context, and it always boils down to the wholly or mainly conveyance of signal. Within the M2M value chain, it's fairly clear that the connectivity service provider is an ECS. Typically, the M2M user is no ECS, but a careful case-by-case approach has to be applied for the time being, as there are so many different types of packages, including connectivity, and business models are just beginning to evolve. But here we also have to ask ourselves the question, to what extent is the framework ready for these kinds of applications with the current definition? Obviously, you don't want to regulate everyone. There are could be high regulatory costs. There could be a high number of licensees if the ECS definition would be extended too far, and that has to be balanced against benefits for end users. Next slide, please. Another issue that obviously is a very hot potato is roaming. Many applications are currently based on permanent roaming. And obviously, permanent roaming, as it's applied now, facilitates a truly European M2M market. However, there may be, if we look at the roaming regulation, currently there is no mentioning of a permanent roaming, and the rationale for M2M need for roaming is very different from what the roaming regulation was intended to do, namely protect consumers traveling across the EU. For that reason, there may be good reasons to ask you the question whether we need a specific treatment here for M2M, looking at the specific needs for M2M applications, where it's clearly acknowledged that that M2M needs permanent roaming. However, the rationale is very different, and it should be acknowledged. Next slide. Here I come to the issue that I was referring to earlier. There is obviously, as long as we use mobile applications, a competition issue if customers want to change their connectivity service provider, because it requires a physical replacement of SIM cards, and very often SIM cards is fully integrated into a device that lives for 30 years. Therefore, it's not very likely that car manufacturers would like to call back their cars to exchange SIM cards. So what are the solutions possible to have competition continuing here or moving here? There are two solutions that are discussed. One is extending the right of application for IoT to IoT M2M users, and the other one is allowing over-the-air provisioning of SIM, where we think this has to be encouraged. There's already some development by GSMA going on. However, we think there could still be some improvement, and this could be an area for the regulator to step in case this doesn't develop into a direction that allows competition. There's another point, when numbers are used, there is an obligation to provide number portability. However, since M2M numbers are never called, this has no again, here the rationale for number portability is not really applicable to M2M applications. Therefore, we think also here there is a rationale for having specific treatment of M2M applications. So it's mainly, shall we foster OTA provisioning, and do we need number portability for mobile devices? And here let me come to the last but not least important point. Obviously, as we said, if consumers don't accept these applications, and all these applications involve their personal data, could be a major barrier to the market. So it's a very critical factor for success that end-user rights and data are protected. The current legal framework with the Privacy Directive and the e-Privacy Directive is there, but there are no specific rules with regard to IoT and M2M for the time being. There is a revision of EU data protection underway, and the aim is to adapt the privacy rules to the digital area. So we think there is no need for very special treatment with regard to principles. However, there should be, or there might be, a need for interpreting and adapting these rules to the M2M context. User-friendly could be different, could impose different requirements for such applications as it does for the classic telco applications. Let me stop here and hand over to Francesco now, who has been leading the drafting team in this project to set the scene with questions that we have devised and for the stakeholders, and we hope to get interesting submissions for our consultation, because that's really an evolving topic where we need your input. Thanks.
Thank you, Cara, for this brilliant summary of the report that we drafted in our drafting team. As Cara said before, this report is now available for public consultation. It's downloadable in the BEREC website, and the public consultation, the deadline for the public consultation is November 2. So we do believe that this opportunity to present the report here is a wonderful opportunity, not only to present the report itself, but also to stimulate your contributions. Of course, our work will depend now on the quantity and quality of the contributions we will receive. So I would like to invite you to contribute as much as you can. I mean, with your views to the report, so that we can we can have a better work and a more structured report at the end of the public consultation process. Okay, from a personal point of view, I have to say that working at M2M has been a very interesting and challenging thing, because the topic is extremely interesting, because we will hear today how the market is developing, how the sector is developing, and we have come across a number of issues on which really we wanted to consult all the stakeholders who would be interested in answer to the consultation. We have elaborated, of course, we will ask for your general comments to the report, but in particular we have elaborated a number of questions that I'm not going to read because they are available in the report. They are in a specific annex of the report. I will just summarize. One of the questions regards the problem of user of numbers abroad that Cara has already explained before. Another question regards the problem of roaming and the relationship between international roaming and permanent roaming in particular, and national roaming, which has created some problems which might create some problems in the application of M2M services within the countries. And then another issue that was discussed also before by Mrs. Jacobs in her contribution, in a previous contribution, which is the switching between connectivity providers. We then discuss, we are then asking some question regarding security and privacy matters, and those matters have been also expressed by Commissioner Oettinger in his speech before. And the last question on which we would like to have your input is a question that regards proprietary standards and the way the market of M2M is developing right now, with proprietary standards which are being being created by alliances of operators. And the important point that would be the possibility of opening those standards, of creating new and open standards. The question is whether this would right now contribute to the development of the M2M services or not, or when it would do it. Also, to start addressing some at least of those questions, I would like to introduce the two panelists that are going to help us in setting the scene for the answers and for the discussion later on. The first panelist that I have the honor to introduce is Dr. Robert Pepper. He used to be the chief of two offices in FCC, the Office of Plans and Policy and Policy Development. And since 2005, he has become the chief of the Global Technology team in Cisco. I've had the pleasure of meeting Robert on several occasions, and I have to say that speaking to him and listening to his views is really enchanting. So I would like to ask Robert to share his views with all of us now, and possibly to start providing us a quick feedback on the report and on the questions that would be of interest for you. Thank you, Robert.
Oh, no, thank you very, very much. I'm going to take this, and I think they're going to put up slides. I don't know, actually I can see them from here, so I'm going to stand over here. So I'm going to talk about, first of all, I really appreciate the invitation to be here with BEREC and to present some of the research that we've done and working and seeing a lot of friends. So I think you know, many of you have seen that every year we have a study we call the Visual Networking Index Study. And it's a 5-year rolling forecast of data with everything to do with the internet. It's devices, it's people, it's connections, it's traffic. And you know, it's a 5-year rolling forecast. We've been doing it for 10 years. So unlike most people who do forecasts, we actually tell you how we did. And once again, this year, we are within about 10%. And we're just using this, for example, this was on the compounded annual growth rate on the data. So I'm very confident in the data. It's not precise, it is a forecast, but it's very close and I'm very confident in the data. And I'm going to focus specifically from this year's forecast on our forecast for machine-to-machine devices. Completely separately, in what I call the tale of two networks, the traffic on the internet and the global networks is being driven by video. Video of all kinds. But the number of devices is being driven by machine-to-machine. And we have a very specific definition. You know, Goran said, you know, is it going to be 200 billion, 500, whatever. We're focusing in the forecast on what we call Internet Protocol-enabled devices, IP-enabled devices, things that have IP addresses. The devices with IPv6, essentially. And those are devices that actually can connect to the internet. There will be billions of more devices that do not have IP addresses, little sensors, RFID chips, etc., that in many cases will be aggregated but connect to each other via devices with the IP addresses. All right, and that's actually very important because it goes to, Kara, one of the questions about, what about IPv6? All of these are IPv6 enabled. Right? So we have to think about identifiers and numbers, right? And so we already know some things about this. And what we're forecasting globally, and I want to make it very concrete for people, because we talk about machine-to-machine devices, but what does that mean? And I'm going to talk about that in a very concrete way. But globally, what we're seeing is that over the next 5 years, globally, 43% of all IP-enabled devices connected to the internet are going to be M2M devices, machine-to-machine devices. And in fact, in Europe, we're forecasting it's going to be 50% of all IP-enabled devices. And over that 5-year period in Europe, right, we're looking at a significant increase in the devices. 76% of all new devices connected in Europe will be M2M devices. So the vast majority of new things with IP addresses connected to the internet here will be machine-to-machine devices. But what's interesting is that although 50% of the devices will be M2M, only 3% of the traffic will come from M2M. So there's this kind of myth that we're seeing this explosive growth in the number of devices, but therefore we're going to, because of M2M, and therefore we're going to need that much more capacity for M2M. The answer is no. Now we're going to need much more capacity, but that's being driven by video and other types of applications, right? But the complexity of the types of devices, that's coming from M2M. It's only going to be about 3% of the data, even though it's half of the devices. So what do I mean by machine-to-machine? As part of the forecast this year, for the first time, we have visibility into the types of devices and the percentage of these devices. And this actually has direct applicability to the consultation. We're forecasting that about half of the devices are going to be in the connected home. And I have specific examples of what that means. But if you think about my connected thermostat, my connected refrigerator, my connected home printer, they don't move, and by the way, they're not going to have SIMs. Or they may not have SIMs, or they're probably will not have SIMs. Right? That's going to be half of the devices. The fastest growing category are devices in connected health. That also includes not just my fitness, my Fitbit, right, which connects to my mobile, my smartphone, that then connects via Wi-Fi, right? No SIM. Other categories that are growing and growing rapidly, the connected car, that will have a SIM. And that is, related to some of these questions. Smart grid, electric utilities, connected work. In fact, if we look at this, and this is an eye chart, I don't expect you to be able to read it, but I'm going to go through these. We've identified there's 9 different industries, we'll call them, sort of verticals, and then there's other, which includes 3 others. And this is based upon the volume, the number of the machine-to-machine devices. So other, which includes agriculture, construction, and emergency services. Right? Some of those are going to be devices that are going to be moving around across borders. Many of those things are not. So let me just spend a little bit of time talking about the types of machine-to-machine devices in each one of these groupings, and then the different requirements of these devices. So, in the connected home, it's going to be security equipment. It's going to be everything from, you're going to have a little security camera. That, by the way, that security camera probably, or the one downstairs when you walk in the hotel, that is continuous. It's broadband, it's video. It's going to be connected with hardwire power, and it probably will have Ethernet. And you have some of those in the home. On the other hand, I will have my thermostat. I will have my refrigerator. I will have my home routing device. I'm going to have my home printer. Those are all considered machine-to-machine devices. And many of them, including my thermostat or even my refrigerator, are not going to be continuous. Right? They're going to burst little bits of data. They're not going to be broadband. And by the way, my refrigerator or thermostat is not sensitive to latency. Right? It can wait to send, the temperature, at least by a few seconds, let alone maybe even a minute. But when I look at things like the connected car, some of that will be, in connected transportation, that will be tied to supply chain. It's also going to, we're forecasting is that by 2019, There will be 250 million connected cars on the road worldwide. Each one of those will have an average of 4 modules that will be connected, and each module will have multiple sensors. Not all the sensors will be IP enabled, but the modules will be. And some of them are going to be connected to things like my tire, my engine for oil pressure, tire pressure, maintenance records. Right? Latency, not an issue. But if it's connected to my airbag that goes off if there's a crash, latency is really important. Right? It has to have a priority. I need it to connect to the emergency service. The other thing is when we look at the assisted driving, not the driverless car, but assisted driving, which already exists. Mercedes is making, large trucks, and they're going to drive in a convoy, 100 kilometers an hour, a meter apart. And every single one of those vehicles need to talk to each other at very low latency, because if the first one brakes to stop, all of them need to know that within 5 milliseconds or they crash. So in that case, by the way, it's not going to be continuous. It's going to be bursting data, but it's going to have to be very low latency. Different types of requirements. In healthcare, one of the biggest problems in healthcare today for patients in hospital is they get the wrong medication. It was the other patient, the other room, or the other bed. Right? So now there are devices that there are the medicine cabinets with the pills, and the drawer will not open unless it talks to the wristband that they put on you in the hospital. So only you get your medication. It's actually saving lives. That's critical. Latency? No. A lot of data? No. It'll burst a little bit. Again, SIM card? No. And yet there are other health-related applications, such as being able to track, and this is a blend of healthcare, supply management, and transportation. So there'll be a vaccine that is manufactured in Switzerland, and it's being taken to a rural clinic in Uganda. If the temperature of that vaccine goes too high, it's not any good. And until now, we can't track that. And so people get vaccines that are not effective. So what happens now is that every single vial, every little bottle of vaccine is tagged, and it's tracked. Its temperature is kept between leaving the factory in Switzerland, all on the airplane, on the trucks, across the entire, half the world to Uganda in the clinic when it's taken out of the refrigerator and administered. Will that have a SIM? Will that have, is it latency sensitive? It's going to be a little bit of data. Very different sets of requirements. In manufacturing, big robots, Hitachi, Fujitsu, robotics, are controlling all of the functions on a factory floor. Siemens is very big in this. Schneider Electric, French company, very big in this. They're not even going to move outside the factory floor, right? Roaming apply? I don't think so. Again, very, very diverse sets of requirements. So let me summarize the types of requirements. Some of the devices are going to communicate over a short distance, some over a long distance. Some of the devices are going to be broadband, some narrowband. Some of the devices are going to be continuous transmission of data. Other devices are going to chirp little bits. In an agricultural field, there'll be a sensor taking temperature and moisture for controlling planting and for controlling remote control for irrigation. Latency is not an issue, and they will be, right, years, right? By the way, they are not going to have a battery. Some of them are going to operate off of what's called ambient power. Changes in temperature and moisture will be a reaction that will have enough power for them to wake up and chirp a little bit of data, then they go back to sleep. Those are called low power devices. The devices are low power, not the network that connects them. And the question, obviously, they're not going to have a SIM. So some of these are going to be high power, some low power. Oh, and then some are going to be very sensitive to latency, and others, latency is not even relevant. So what is the value of all of this together to society? We did a study 2 years ago looking at what we call the value at stake for the Internet of Everything. And we make the distinction between the Internet of Things, which are these M2M devices, that when you connect the dots and you do the analytics and you can change process and change behavior, there's an economic impact. And that economic impact we thought was a crazy number. It was $19 trillion globally, and in Europe it was $6.3 trillion US over 10 years. So about here, about $630 billion US annually in Europe. And you can see the impact, almost $1 trillion in Germany. And then that can be broken down. Now, we thought this number was just way too large. And then McKinsey did a study last year that actually made this number look small. The point is not the precision of the number, but when you do the analysis and unpack the number, we can break it into different industry segments. And since we have both, the chair, former chair, new chair, I have actually two examples, one from Germany, one from Portugal. In Germany, and this, by the way, if you look at the impact, the economic impact over 10 years in Germany, we're estimating just on the smart factory about $120 billion US a year. For 10 years, about $12 billion a year. Increased gains of this value at stake by the application of not just the device, but the architecture, the analytics, the economic value that you can take from that. And you can see supply, logistics, physical security, supply chain, smart grid, smart buildings. Most of these are not moving devices, or if they move slowly, and they're not going across borders. Although the devices, the chipsets are going to be global, right? These M2M devices. In Portugal, it's about a $6 billion a year, about $62 billion over a 10-year period. And again, smart factories are about 10%. The smart factory, smart manufacturing is between 10 and 15% of the economic value of the Internet of Everything architecture based upon these M2M devices. So I mentioned that Europe, about 50%, it's above the world average of 43%. But what about if we look in Europe, it's as high as 61% in Italy, interestingly, Francesco. And you can see that, but it's not among, there are other countries also that are very advanced. US, Japan, and Korea. In Korea, 72% of all of the devices connected to the internet in Korea are going to be M2M, with a very, very high percentage, not just in the connected home, but also in the manufacturing space. But I'm concerned that we're seeing, it's separate from this conversation here today with BEREC, what I'm seeing in the forecast is an emergence of a new digital divide on M2M devices. If you look at Latin America, 31%. You look at Middle East, Africa, 17%. India, 13%. And there is, by the way, a disproportionate economic and social benefit in emerging countries for the Internet of Things for development with things like food security, water security, disease detection, that unless the emerging economies also have high levels of deployment and adoption of M2M devices, well, there'll be a new digital divide, but that's for a different conversation. So, takeaways. Number one, IP-enabled machine-to-machine devices are growing fast, and it's the fastest growing category of devices connected to the net. But number two, it's a wide range of M2M devices for a wide range of uses. The majority of these will not be mobile. My refrigerator doesn't move unless there's an earthquake, right? And then it's not going to move very far. Most of these devices, by the way, are not going to have SIMs, but there'll be a subgroup that will have SIMs that are very important. But thinking about this through the lens of traditional telecom regulators, roaming and SIMs and permanent SIM or national SIM, and doesn't even map, right? It's important for a subset, but not across the entire value chain and where there's huge economic benefit. We are going to have a very, very heterogeneous, diverse set of device requirements. As I said, some are going to be long distance, some short distance, some bursty, some continuous, some broadband, narrowband. Some are going to be connected all the time, some not. And then latency. The environments in which they're going to operate are very heterogeneous. At home, in the factory, in the hospital, in a car, on airplanes. You know, the plane taking off from Beijing and landing in Brussels, generating all kinds of data from that engine, right? So that Rolls-Royce knows when that engine needs a part that's replaced, so it's sitting at the Brussels airport to be put in the engine when it lands. They'll know that before the pilot. Heterogeneous spectrum requirements. You're going to need some spectrum for short distance. You're going to need some spectrum for long distance. And we can talk about some of these specialized networks like Sigfox and LoRa, and even what's happening within 3GPP with the extensions on the LTE standard for something called LTE MTC, which is machine-type communication. And finally, it's going to be a very heterogeneous set of regulatory requirements by different regulators in different environments. And it will be some of the people in this room, and then it's going to be government departments or regulators in completely different industries. Completely, totally different industries. And later, maybe let's talk about the standards and interoperability and where those standards are being set. You know, one thing to talk about is a new industry group. It's 16 months old, called the Industrial Internet Consortium. It started out 16 months ago with 60 companies. It now has over 200 from around the world. Bosch, SAP, Siemens, are just Schneider Electric are just a few of the examples of the European companies that are leading within the IIC for the standards for interoperability and working groups on things like security. So that's a context, and I look forward to the discussion specifically on the consultation. Thank you very much.
Thank you, Robert. As usual, your view and your speeches open new views and new possibilities and boundaries for the discussion and for thoughts for the regulators. I was personally very interested by seeing the share that Italy has in the number of M2M devices, second only to Japan and Korea, and that's really interesting. And also, I found it very interesting to hear that your opinion is that there is a huge amount of different devices, a huge amount of cases of applications of M2M, which require, of course, completely an heterogeneous system of regulatory system. Now, the problem for us is also to understand what are the boundaries of the regulatory activity, whether the regulatory activity should, in this case, how better the regulatory activity should help foster the development of the M2M, and in particular in fields in which it is questionable whether the competence belongs only to one regulator or to many regulators, etc. You were raising the point of connected health, which of course raises a lot of doubts related to security of data and in particular to privacy of data, exactly. So to that end, for this reason, we are particularly happy to have Cornelia with us, our second speaker. Cornelia Katter is a German lawyer. She's leading Microsoft digital policy strategy, and she has been representing Microsoft in privacy and security issues at the European international level. She was also the head of the legal department of BEUC, the Association of Consumers, which can be very useful also in this discussion. We are very happy to have you here, not only, mainly, of course, to have the view of Microsoft on the development of this sector, but also to have your view on these issues of security and privacy from both the view from the perspective of a leading software company, but also, if you wish, from the perspective of a person who has been working in the consumer's environment. So that would be very interesting. Thank you, Cornelia.
Thanks a lot, and thank you very much for inviting me here today. I must say, when I first got the question to talk about IoT, I was immediately responding to Francesco, saying, hey, great, something I do. And then I was reading the report, and then I was panicking. It's like, this is not really what I do. I don't have anything to say. I will try to give a little bit of a different perspective. And the first thing that I would want to say is we came from being a software company, and now everybody is a software company. And that is really the change that we have been seeing and the change that IoT will bring. And the one word I haven't heard yet, what we believe this is all about, is data. This is all about data. And connectivity, to a certain extent, is a feature in that space. And why is it so important, and in particular in Europe, is because it's about the revenues of every single company and every single sector. So what Commissioner Oettinger this morning was saying is absolutely right. There's data that shows very clearly that those companies that apply and adopt IoT and cloud will have better information to serve their customers, and there's already first studies around the fact that these companies succeed in better stock evaluation. So at the end of the day, it is a question about survival in that space. The digital transformation of each of those sectors that Robert was already mentioning is absolute a prerequisite for them to be competitive on a global level. And so Microsoft has been able to move from being a software company to being a cloud provider. And when you think about the last couple of years in the IoT space, I think Robert is a well-known figure because Cisco has been around for a very, very long time in this space. In 2014, Forrester had a very nice prediction, and that was we can finally forget about how many connected devices we have, because it is about the application in each single customer's environment which counts, and that is where the platforms really kick in. So the platform cloud providers are the new kids around the corner that will enable IoT to bring the economic benefit that we see. And so in order to better understand really the economics around and the competitive dynamics in this IoT market, it is really interesting to look at the details and the stacks that are in there. This is a very simplified model. Let me go a little bit more in detail. There's devices and assets, the things, and they connect to a cloud infrastructure, which will provide the data analytics that then drive the insights for the business transformation. in that context, let me explain where Microsoft is and why we haven't been playing so much in this, how many billions of devices are connected. Microsoft plays just a certain limited role in the devices. We have a band, so a health lifestyle device. And then we have Windows 10, Windows Embedded, which plays an increasingly important role. But mostly, and that is something which you will see more and more features, more and more services added on, is Microsoft Azure is our cloud platform on which the data analytics, the machine learning really, really drives. In these IoT systems, you have really a number of attributes. Natural user interfaces, so the intelligent, the personal computing. You have touch, gesture, speech, video analytics around natural user interface. You have identity. That is a bit of a security issue insofar as you need to have the ability to connect and deliver the right data in the right context to the right person and machine. You need connectivity, of course, as an attribute, ubiquitous two-way on-demand connectivity between the edge device and the cloud. And again, the cloud is really one of the key elements here. Security, I mentioned already, both in the machine as well in the data. Manageability, the ability to update, manage, program machines remotely from any location based on the company or customer requirement. Analytics, how do you capture the data in the system? And the knowledge graphs, really what you get out of the data. So Microsoft does focus on personal computing, intelligent cloud, intelligent devices, to a certain extent, to data connectivity, intelligent operations, ambient intelligence, and marketplaces. Let me go back 1 second. So we heard already about we already heard about the different verticals, the sectors that will drive most of those changes and digital transformations, and Microsoft is definitely very, very invested in many of those. And we think about the usage for these verticals and how they will digitally transform. And you have basically scenarios that are relevant across all these sectors. And I just mentioned a couple of them, which is asset management, remote monitoring, servicing, asset tracking, geofencing, personal digital assistant, compliance management, data visualization, analytics, predictive maintenance, robotics, enterprise integration. There are a couple of more, just to see that with such a platform, the applications and the scenarios, they are actually relevant in all of the sectors. And this is an important point to mention in the context of standards, as standards are currently evolving in that space. Now a little bit on the market opportunities, and I think that is eventually relevant also to see what's going to happen with the telecommunication reform, because the telecommunication reform, in my view, will actually define how cloud and IoT providers and telecom and connectivity providers will position themselves in the market. And I guess to a certain extent, companies like us are not very familiar to such an environment, which is much more regulated. Let me give you a couple of data points which make that relevant again. So we have these 25 billion connected devices, and they will produce a 40% combined annual growth rate in data. The estimates around the global economic value, they differ from analyst to analyst. But for example, there is one which is Gartner, that says it's $1.9 trillion US dollars by 2020. The biggest industries, and this is where most of the cloud providers and IoT analytics providers will focus on, is manufacturing, healthcare, insurance, banking, retail, electricity, urban infrastructure, and security. These trends, they are as Robert mentioned, they usually are rectified to growth rather than anything else. But you can see that even so, a company like Microsoft is late in the game. When you look at the potential revenues, they really lie in the data. So I come back to my first point. This is about data and nothing else. It's about data insights. What does that mean? We heard about M2M connectivity, and obviously nothing in our world these days is more important than connectivity. And having been in Microsoft for so long, I see the developments around the discussions and where connectivity stays and is. And one of our key business groups is the business development group, and that is where connectivity is. And then where connectivity also plays a role is in our cloud and enterprise role. Those are the ones that build the data centers out in Europe and across the world. We also actually invest in infrastructure. We invest in undersea cables. We invest in interconnection. We invest in Wi-Fi. We try to build alternative ways for connectivity in emerging markets in particular, but also wherever we see there is a market opportunity. Nevertheless, it is interesting to think about how the business model's evolving, and maybe we should no longer say an ICT ecosystem. It's really an ICT ecosystem. It's a system of partnerships. The partnerships that are evolving are very diverse, and they're changing. And it will be, with the revision of the telecom framework, we will see how the connectivity providers, the cloud and IoT providers, will partner with each other in order to provide the best services to the customers. With that last point, I was asked to talk a little bit about IoT and security implications. From a cloud provider's perspective, has invested quite a bit in security. There's not that much change really in the IoT world. So we apply security frameworks and evolve them from our cloud perspective. But of course, there are new questions and issues that we will need to address. And just to give you a couple of them in the context of standardization initiatives that are currently underway. In the context of security, you need to think about the protection measures that involve a combination of deterrence, avoidance, prevention, detection, recovery, correction. And it needs to become part of the enterprise's risk management that applies applies IoT and transform itself. The privacy risks become more difficult. There will be ethical questions we will have to answer, and we can discuss this a little bit more in what types of privacy risks there are increasing. Certainly, the data collection is different in IoT, and through the insights, you have different means in identifying data subjects. So we'll have to think hard about how we can work together. Maybe we can also discuss afterwards a little bit the e-privacy directive and where we are there. There is other issues around safety and reliability that are increasingly important, and the resilience, obviously, in particular, as in IoT scenarios, you have a different situation than you had on internet or just cloud. In IoT scenarios, very often you have physical harms that could happen that we didn't deal with before. So we'll have to think about liabilities differently. We'll have to think about data ownership differently. So there are a couple of issues that are unsolved, emerging issues, and I'm looking forward to that discussion. Thank you.
Thank you, Cornelia. Thank you very much. I'm glad that you gave us this insight on the perspective of Microsoft, because you made us understand how important also the cloud dimension of the IoT. And of course, this refers to what we were saying before about security and privacy. You just mentioned them. I hope in the contributions to the public consultations there will also be the possibility of talking more in detail about the necessity, whether you think it would be necessary to have a review of the Privacy Directive or the e-Privacy Directive, and as far as security is concerned, maybe the Article 13 of the Framework Directive, in order to give us some ideas on whether those could be things that we could suggest.
Maybe I can already say one thing about the security, if I may. It's interesting that you're asking this question now, where we had a 2 years discussion on the NIST directive, the Network and Information Security Directive, where there is still, I think, an ongoing discussion in the Council whether or not to include internet enablers and cloud providers. And that question from you is sort of the proof point that the idea to put that in a separate directive and think about it in the context of critical physical infrastructure might have not been the right choice, but really think about security in a broader IoT context. So now it's in principle somewhere else.
Yeah, indeed. Thank you very much. I also had one question for Robert, but I think we don't have much time, unfortunately. I would like to ask whether we can extend this panel, the duration of the panel, by like 10 minutes, so that, because I would like to open the floor to contributions. I would like to ask whoever, well, during the coffee break, there have been a number of people who were interested in delivering a contribution, so I would like to ask you to present yourself, your company or your institution, and make statements possibly brief, and possibly, again, statements. Of course, we will welcome questions to the panelists. We would like to have your views on the report in general and the topics that we have addressed specifically in the questions, if it's possible. Thank you. Who has the microphone there? Yeah, I would start with, I think Professor Horan can raise the hand first. Thank you.
So thank you very much. My name is Thomas Hörn. I'm a law professor, one of the rare guys here, law professors, from the University of Münster in Germany, and I'm specialized a little bit in the legal issues of connected cars. Therefore, in some short statements, a car is not a telephone. That's very important to notice. And a car has a tendency to travel across borders. So we have a big problem. And the problem I think is mentioned in the draft report, but I'm sure that not every aspect is mentioned which should be there in the report. There are more problems with the telecom regulations than was mentioned in the report. So, for instance, we have a right of the person who is using a car for being mentioned in a public directory. We have a right to block numbers. We have a minimum requirement of telecom standards, of telecom contracts of 2 years. So how does it fit into the world of a car? And another topic which is strikingly not mentioned in the report is the topic mentioned by Mr. Oettinger. That is the question, who owns the data? Yeah. If we have the SIM card, who is saying that the SIM card is owned by the customer, the end user? It's owned by the car manufacturer. So it's a totally different situation and should be aware of that. And the last critical remark, in the draft report, you mentioned IPv6 as a big solution. You should be aware that IPv6 is very dangerous in the world of privacy, because we have lost the chance to have dynamic IP addresses in the IPv6, and that it has a lot of consequences for privacy issues. Thank you very much.
Thank you, Professor Horn. If you agree, I would proceed this way. I would gather a number of contributions, and then I would ask the panelists to answer to the questions that they think that would be more relevant for their competence, etc., and we proceed this way. Antonio, thank you.
Thank you very much, Francesco. Antonio Amendola from AT&T. I would like first to congratulate BEREC and the drafting team for this very valuable job in drafting. This is one of those times where the questions are the right ones. Usually when we are facing a totally uncharted territory, like this revolution that we're going to see in a few years, the first mistake is to ask the wrong questions. I think that the draft report is going toward a very encouraging direction, so I congratulate with you, with Cara, and with all the other teams of the members of the teams. Let me just focus on very specific issues, which is the numbering issues that you mentioned. We could talk for hours here today, but this is not the case. I think global IoT services, new services, need innovative and creative numbering solutions to address the requirements of both IoT services and customers and product manufacturers. At the same time, I think the most effective probably and the quickest solution will be to allow the extraterritorial use of numbering resources. I personally do not think that it will be extremely efficient and effective to add and to create a further layer like the M2M European space, numbering space, that has been lately invoked and proposed, in between the national resources and ITU numbering resources. That is to say that NRAs should probably allow their national number resources to have an extraterritorial enlargement of their scope, and at the same time allowing foreign numbers to be used at their national levels. I think this will incredibly and very effectively add to the competition. Of course, I could turn this into a question to the panelists, but this is more a statement than questions. But if you have time to address that question, I would be very grateful. Thank you.
Thank you, Antonio. Yes.
Thank you. Vladimir Bocquet, GSMA. First of all, we'd like to welcome the opportunity that BEREC has granted to all the stakeholders to engage in the positive dialogue regarding the policy and regulations for the IoT. It is recognized that socioeconomic impact and the value associated done by the mobile operators and the other IoT supplier can be delivered and is tremendous. That includes benefit from citizens, consumers, business, and government. We understand that we can have impact on reducing the healthcare cost or improving quality of life, reducing carbon footprint, also improving transportation safety across Europe, as the previous speaker mentioned. We recently published a study showing that the mHealth could save 99 billion euro in healthcare costs across Europe. But also we should recognize that the IoT is a nascent industry, and its value chain, business model, market, and services are fundamentally different from the traditional telecommunications services such as voice or messaging. In that case, we would like to encourage the different policymakers and BEREC to ensure that we are a pro-investment environment which is established and maintained across the IoT value chain. In order to realize this significant social and economic benefit, as I mentioned through an example for healthcare, we need to ensure that policies and regulations are relevant, flexible, balanced, and techno-neutral. I think Dr. Pepper mentioned also this techno-neutrality or service neutrality, since we are working across a number of networks and in an heterogeneous environment. So just to summarize, we believe that consistent regulations need to be applied with clarity and legal certainty across all the IoT players. We also want to ensure an appropriate level playing field, and also, just mentioned by previous speaker, also to apply a privacy and data protections regulations appropriately across all the IoT providers. And also building trust, because at the end we think that the consumers will rely on trust and believe that having these trusty relations across all the value chains proposed by the IoT will make complete sense and will help to develop this nice opportunity for Europe. Finally, we will develop with our members a detailed response to the public consultations, and all the details and elements that I just briefly introduced will be further developed in our consultations. Thank you.
Thank you. Thank you very much. They're the same table? Yeah.
Good afternoon, everyone. My name is Freddie McBride. I represent the CEPT. You would have seen the CEPT in one of Kara's slides, and we do a lot of work harmonizing policy for the use of spectrum and numbering resources in our 48 member countries in Europe. So I have a comment in relation to the BEREC report. I think it's a very good report. I think it provides a comprehensive basis for an exchange of views on resource management for M2M and on the competition and switching issues. And just there was a comment from the floor about the extraterritorial use of numbers, and I think that one of the issues with that is that the burden of providing the addressing resources falls disproportionately on one or a few different countries. So as long as there's transparency and coordination in terms of that use, then I think you could have a possible solution. But I don't think we should be looking for winners and losers in terms of what is the best solution. I think if Dr. Pepper mentioned, I think the main message in his presentation was to cut through the hype about the number of devices and how many of them will actually have a SIM card and be used in mobile networks and require public resources. I think from a spectrum point of view, a lot of the applications in M2M will find their home in the spectrum somewhere without huge changes to spectrum policy. Numbering is a bit different. But in the BEREC report, there's a question, I think it's question 3, where it mentions, asks the reader to express a preference between an administrative solution for the provision of E.212 mobile network codes and IMSI ranges versus a technical solution. And at this stage, I'd be very cautious about actually seeking preferences. It suggests that as policymakers and regulators, we're looking to back winners and losers in this, and I don't think we should be doing that. If you look at some of the applications for M2M, let's say if somebody has an application that requires connectivity for 50,000 devices, should you give them an addressing resource with 10 billion units of an addressing space? Probably not. That's not very efficient. But then on the other hand, looking at the over-the-air provisioning solution that's being standardized at the moment within ETSI, and the GSMA has a specification on it. If you look at that, and again, Dr. Pepper mentioned this, a lot of the applications are bursty in nature. The devices sleep, and then they wake up, send a little bit of data, go back to sleep. And that could be by design for privacy reasons, which is very important. It could be because of something as simple as conserving battery power. And if you look at like some of the big applications that are going to come online, like eCall, the eCall device might never connect to a network, except for testing. So if you look at remote provisioning as a solution, how are you going to remote provision all of these devices that aren't even connected? So my message would be not to be backing winners and losers and picking particular technologies, but to consider that we need to have a competitive environment and to keep in mind that there are lots of different solutions and some might suit some applications and others might not. Thank you.
Thank you. Thank you very much. Yes.
Jacques Bonifay, representing the MVNO Association. So we see some of our members, including my company, trying to develop some worldwide data MVNO solutions, where in some cases it's quite useful to be reachable with a mobile phone number. So of course we could use, and that's what we actually do today, international numbers which are not French, not European. I mean, although I am French, I don't like to use French number because I do a worldwide business. So I don't want to have a number which is attached to a specific country. I don't think it's good. So I welcome to have some European number range because it's a first step, and I like to be sure that those numbers will be implemented with each operator so that it's actually reachable. Because one of the problems when you are a newcomer, you issue number range, then it takes lots of time to be sure that those numbers are reached for voice, and especially on SMS. It actually takes a very long time to be reachable for incoming SMS. So I think there is value in having a European number range with a low MTR, because we don't want people to do some strange business with high MTR. and ensuring with the right regulations that those numbers are reachable within a fairly short period of time.
Thank you very much. Again, one very valuable consideration. I think there is one mic down there. Yeah.
Yes, thank you. Hello, good afternoon. My name is Marco Hoogwaning. I work for the RIPE NCC, the Regional Internet Registry. And I would like to thank all panelists for their informative presentations. Discussing numbers, I would like to draw attention to the fact that numbers serve usually one of two purposes. And one is the identification part, who is talking, that you for instance see with SIM. And the other part is getting the actual message to its destination, the addressing part in terms of network address. And what I would love to hear the view of the panelists is how they see the balance there, because for instance, IP addresses generally are dynamic in nature, especially with nomadic use. These things change as you move from one network to the next. Where for instance, phone numbers are very static. If I roam from one network to the next, my E164 number stays the same and I stay reachable. And in future evolutions and in convergence of networks, how do you look into where the priority should be? Should it be the identification part, or should that be the routing part? Or should we develop actually two systems that overlap? Thank you.
Thank you. Any more contributions or any more? Yes, sorry.
Yes, Francesco, I think it's a hot day today because even the robots are listening to us on the internet. Just more seriously, we got also a tweet which is related to Mr. Pepper's presentation from Edgar Aker, who said that indeed, thank you very much, Mr. Pepper, to be so specific, and especially what M2M actually is, and the connection with the discussion about latency. Then, of course, when we have a discussion about roaming, privacy, connectivity, switching, and so on, one of the questions raising now is also about, do we need different quality of services for different type of IoT services?
Indeed. Okay. I don't... Yes, Tanguy.
Yes, maybe a last intervention, if I may. My name is Tanguy van Overstraat, and I'm a partner at the law firm Linklaters, and I would like to give a different angle because I will have to apply all these rules in the future for my clients, and I think it's important to ensure that these rules are legible, make some level of certainty. I think the point has been made very clearly by some of the panelists. And I wanted to address in particular question 5 of the BEREC, and I thank the BEREC for first the report, but also for the questions, because that gives us, of course, the opportunity to answer them and to voice potentially our opinion and concerns. And there are two aspects on this question. I remind you it is a question in relation to data protection. First of all, whether the current framework, 9546 and 2058, should be modified, knowing that, of course, there is the new regulation which is upcoming. I would like to answer this one, because one of my concerns is really that the 2002-58 is a very sector-focused document, and this is, I think, contrary to what the regulation is due to do, because the regulation is technology neutral, and it's supposed to, in fact, provide the principles, the protection for all types of sector. I believe this is the best approach, in my view, and I strongly believe that, in fact, the 2002-58 should be revised to avoid having companies in the sectors which are subject to the 2002-58 being caught by the two texts and being, of course, also faced by contradictory rules. There is also a second aspect which is made in, which is addressed by the question, which is what do we think about the document? Is it going in the right direction? I'm talking about the regulation, the draft regulation. And there I would like to make two comments. One is that I think the document, the general approach which has been approved by the Council, by the European Council, is in my view a more business-friendly approach. It is more, let's say, considering the risk-based approach which has been hammered by the industry, and therefore for that I applaud the effort which has been made. The concern I have, however, is that the price to reach that level of, let's say, business-friendly approach is also a certain reduction in terms of harmonization. And if you look, of course, at the details of the general approach, you see that there's a lot of room left for the national authorities. I think in a global world, and we have insisted on that during the presentation, I think it's clear that we should have something which is perhaps even more than European. It should be global, but of course we have to do it step by step. And therefore, I think I would plead very much for more harmonization in the text, which will be hopefully finalized in a few months. Thank you.
Thank you very much. Okay, I think we can close the contributions. I would like to give, well, time is running unfortunately, so I would like to give the time for a final comment to each of our speakers. Maybe we can start with Cornelia, I don't know whether you want to react to what Tanguy was saying, or there was another statement regarding the ownership of data before. And then I would move to Cara, who might be interested in answering to the statement of connected cars, and then to Dr. Pepper, discussing the issue of switching and the standards. Very briefly, I don't know if you want to start. Thank you.
Okay, so on the data ownership, it's a really it's clearly one of the key new issues that we will be dealing with in the digital single market initiative, has been clearly stated. Two things here. One, from a Microsoft perspective, what we do to convince our customers to be assured. It is interesting to note that we talk about the Internet of your things and your data. But at the same time, when you think about the regulatory environment in Europe, there is actually, it's a new concept which is put out there, which doesn't stick to data protection. It's not a concept that links to data protection. It is a concept that links more to contract law, to civil law. But then we also have already existing law in yet another field, which is IP. We have actually a database directive. And I haven't seen yet, and maybe that is something for you, Dr. Hearn, to think about how the database directive would apply in an Internet of Things environment. It's certainly not made for that scenario because that didn't exist at the time. And I might also say that the Commission at one report evaluating the benefits of that directive mentioned very clearly that they didn't actually see any value, yet they didn't abolish it either. But it would be interesting because nothing else than databases are the backbone of data analytics. So it could be an interesting issue to evolve before starting new laws. And clearly it would need to be delinked from any personal data, which is very, very often, and that comes eventually to your question, very, very often a problem. Much of the data analytics we talk about is not about personal data. So it would also be good for policymakers to very often distinguish these two issues. On the e-privacy directive, I say a personal view on I think this will be the next big issue in Brussels in the next year because it is huge. I predict that a lot, I understand there is stakeholders that asked to abolish it entirely. It's an evaluation to be done in how much the general data protection regulation would cover all those scenarios and cover it correctly. I doubt this is going to happen. So we'll have to see what makes actually sense. There's a clear ask for extending the e-privacy directive, which would bring those stakeholders that are not yet part of the e-privacy directive under what you were saying in this legal uncertainty, which one is the one that actually addresses us and covers us. And I guess that's maybe as a last remark, a general problem that we are seeing in having all the ICT regulatory framework being revised at once. We see this, we have the consumer protection laws currently revised, while at the same time you think about extending the scope of those consumer protections, which again could be the same similar situation being trapped into two laws. So I would call for cautious approach in simply looking from your perspective and then extending to other areas. And that is sort of the last point that Robert was mentioning. There are other national regulators and other enforcers that are looking from a different perspective on the same thing. So you should have that in mind when you regulate.
Indeed, and that's not easy. For sure. Thank you very much. Kara?
Well, I just wanted to make a very short clarification with regard to the fact that, yes, we do recognize that cars are not telephones, and therefore the way we have classified the car manufacturers is as M2M users rather than the connectivity providers, coming to the conclusion that usually they would not be classified as ECS, and therefore they would not be subject to the obligations that you were just mentioning. We are very much aware that if you extend ECS to sort of everyone in the digital area, we are sort of we don't want this burden of regulation to make it short. Thank you.
Thank you, Robert. The last word.
That's the right answer. No, there's a lot raised here, and I do think it's exactly the point, Cara, that you made, which is, this world of M2M is very, very broad, and it's going to be applied and used in so many different ways in so many different industries that thinking about it just from the perspective of traditional network operator regulation is just it's important, but it's only one lens, and thinking about that as the lens to see the entire world would not be appropriate. I mean, it just won't work. So your answer is absolutely correct, and we can't make the assumption that just because part of it looks like something we used to know from the 1990s, it doesn't mean that it's going to be that way in the future. So we need to think about it broadly. And just even one question related to, the data from the automobile, right? How do you even grant permission or opt in when there is no, graphic user interface to read what it says and click yes? Is it the first time I put the key in the car and turn the engine on? Is it implied consent or not? Probably not. And do we even want to permit people to opt out on the data if it's about road safety and information in a crash, or information between cars when you're driving fast? Should I be permitted to opt out from sending, the data from my car to other cars around me so that I become invisible? Boy, probably. I mean, I don't want those invisible cars on the road if I'm driving. So even the notions of how we thought about this when it was all about my device, my smartphone, and me, as a person being on the internet, is very different than we're talking about the machines. And we have to think about it, I think, in that broader way.
I think that this message is the message, the messages that we heard right now are the message that we will really, that we're receiving today, the most important ones on which we will need to think a lot. And that's probably also a message to the colleagues from the European Commission, who were thinking of changing and revising the whole framework. Probably this is something that it will be important also for them. Okay, I beg your pardon for taking some time, or for some more time than it was expected, and for taking you from lunch. I think that we can close the panel here. I would like to thank all the contributions, and of course all the speakers were close to me. I think it was a very interesting panel. We learned a lot from it, and we are waiting to receive the contributions to keep working on this. Thank you very, very much.